Hello everyone. Can someone confirm if they can see my screen?
Yes, yes.
Yes.
Do you see the APIC
Yeah,
screen?
with Cisco one.
Cisco, perfect. So give me 2 minutes. I'll just quickly start with introduction and everything. One.
Yes, your screen is visible now. You make this lab, made this lab, or you are working somewhere or working on live network?
Hey Jasveer. Um, yeah, I can hear you. So
Yes, yes.
yeah, Jasveer, give me 2 minutes. I'm just opening up things. So let me open this Cisco CCNP DC. Okay, so first of all, uh, very good evening to everyone, or good morning if you're joining from other parts of the world. Uh, my name myself Samir, and I will be your trainer for the Cisco ACI. So, uh, before we go into the class, I really appreciate all of you taking out time and attending this demo where we will talk about Cisco data center. We'll talk about Cisco ACI application centric infrastructure, and we will get to know more about ACI as we go throughout the lecture. So first of all, if like I'm too fast or I'm too slow, you can just let me know. I would really appreciate that. And if you have any questions that is you know at the time of the topics I'm covering, you can definitely ask me, or you can also ask me at the end of the session as like whatever you like. And so first of all, I'd like to know about few of your people, because I see total 19 have joined. Uh, we have a full house. So can someone, just go unmute yourself, give the introduction, like name, the role or company they're working, and why, like, what motivated them to join a Cisco ACI class on Saturday evening. So anyone would like to tell everyone? Just to I this is just to understand the type of audience that I have and your expectations, so I can uh, better give you information as per that. So who would like to go first? Anyone?
Hello.
Okay, I will go ahead. My name is Uday, and I'm interested just to know there is a lot of business value which is coming across from Cisco ACI, and a lot of big organizations are implementing these solutions, right? So, want to make myself acclimatized to this environment. Thank you.
Perfect. To that, do you have like a networking background, or this is like totally new to you?
I'm a CCNP, so yeah, have a networking background. Thanks.
Great, perfect.
Uh, Hello, Samir. This side Jasveer.
Go ahead,
Actually,
Jasveer.
I have worked on ACI approximate 1 year in Nokia, but that was Nokia ACI, Nokia Solutions. and I want to learn on Cisco ACI. I learned from the books, but I want to see the practicals. That's why I'm here.
Yeah, sure, Jasveer. Thank you so much. And I assure you, we are going to have lots of labs, lots
Uh,
of on-hands
I
practice
I
here.
want to know you will cover EVPN like EVPN, multicast, multipod. Actually, I have lots of doubts in that
Sure,
EVPN.
Jasveer. So yeah, I would go through the syllabus after this. I will tell you
Okay.
what we are what I'll step by step tell you what we will go in deep, right? So today is a demo. I will just give you a demo of understanding of ACI, its components, so that you can better know. And
Yeah.
rest assured, rest assured, like your queries will be answered, and we will go into as much depth as possible as per the syllabus, so that you are very well covered and know about that technology. Okay.
You are owner of Network Journey channel, yeah, you are Twitter.
i'm
Hello?
a, I'm a trainer, Jasveer.
Okay.
Yeah.
Okay, okay.
Anyone else?
This is Hari. I'm from a ISP background, the core routing and switching from last 15 years in Mumbai. Yes, I'm thinking there is the latest technology, the boom of AC I've heard about in many people's mouth. So I thought then I need to learn that thing. That was the reason I joined.
Yes, great. Thank you so much, Hari. Yes, definitely. This is one of the most emerging and most on-demand technology right now,
Okay.
be it technology wise or be it like job wise. There's a lot of openings for now ACI with like good pay and packages. So yep, welcome to demo. I will just take one last. Anyone want to share, and then we will start.
Hi Samir, this is Srivani. I'm in networking background since 4 years in core routing and switching, and I want to upgrade my skills to this Cisco ACI.
Perfect. Thank you so much, Shivani, for sharing that. Yes, that's so. I see that all of us are, most of us, right, are like have a networking background. So that's a very good thing because this technology is network core, and I just wanted to know if someone is from other domains so that I can uh teach like that. But it's good because I can talk network to network, router to router, switch to switch with all of you guys. So that is great. So okay, sure, let me now start. Do you see my screen? Is it visible?
It's
Yeah, it's
visible.
audible.
Yeah, it's visible. Good. So you see my Chrome, right? Cisco CCNP data center certification.
Yeah, yeah.
Okay, thank you. Sorry. So okay, let's start. So uh welcome all of you. This demo is for CCNP data center Cisco ACI technology. Okay, so if when you talk about data center, data center, there's lot of technologies in data center, right? But the one which I'm going to teach you through this demo, and in the upcoming classes, that will be Cisco ACI. So I would just like to touch base about certification very like in a very brief, so that everyone is aware. So we all know about Cisco CCNA, right? Where's my title?
Right.
So yeah, sorry, what is this? Okay, we all know about CCNA, right? CCNA is our basic for Cisco certification. We have that CCNA is like basic certification, Cisco Certified Network Associate. Then we go for CCNP, okay, which is like Cisco Certified Network Professional, and then we have CCI. Okay, now the track that we are doing here is data center. Okay, so in data center right now, there for like previously it used to be a CCNP. The track pattern was different, but right now the track pattern is that you need to, in CCNP, there are two parts, right? There are two parts. One is a core, okay, and one is specialization, right? So there are two exams that you will have to take to call yourself a CCNP, a fully CCNP certified, which is one core, one core exam, which consists of almost like all the data center topics, and one specialized exam that is like, there are 3 4 tracks. I think 5 6 tracks are there. Okay, ACI, then there is Nexus, then there is implementation advanced. So these are all so you just need to take this one core, and and the second one that you need to take is one of any one of this examination. So this one examination that we are talking about is like Cisco DCACI, data center ACI. So that is how the certification path is for DCACI, right? Clear. All right. Now, if you come here and you see, this is a Cisco official website. If I go to exams, um, okay, so this is called concentration. The specialization is called concentration. So there is like one exam will be the core, and the other one, two, three, four exams. There are 4 exams which we call as concentration exams that you can take. Okay, so this for like previously, it was important that you take the core or written exam, CCNP written exam first, but now Cisco is like very flexible, so you can like you can go with the core exam, or even you can go with the concentration. It totally depends on you. If you want to pursue, like, you just want to get DCACI examination done. Okay, do you just want certification in this? Okay, go ahead. So Cisco says, okay, go ahead, book this exam, give this exam. You'll be a DCACI specialist, right? You'll not be called CCNP data center, but you'll be called CCNP specialist. And then when you clear the core, then you will be called a fully data center CCNP data center engineer, right? So that's how, like, they have just segregated things. So the exam that we are looking here is implemented Cisco application centric infrastructure, right? So this tells passing these exams earn you the Cisco certified specialist data center ACI implementation. You see this, the word that differentiate it is specialist, right? As well as helping you work toward your CCNP data center career. So for getting a CCNP data center, you just need to also clear a CCNP core data center exam. So there will be one more exam. Okay. So this is like minutes, how many dollars, and other things. If I go to exam topics, so this is the exam. This is like standard exam topics of DCACI. Okay, it's a 90-minute exam, and these are all the topics that will be covered in our classes. Like when you join our class, when you join these classes with me, we will be covering all these topics. Like we have 15 or 16 weeks course, and we will deep dive through all of this. So describe ACI architecture, topology, hardware, virtual APIC, ACI object models is there, faults, events, audit log, discovery of the ACI fabric, policies in ACI fabric. Okay, then logical constructs. These are very, very important. Tenant. So basically, this is like the logical backbone, how the ACI or the APIC is basically profiled, right? So these are, I would say, these are like not so hard to understand once you know that what it is. It's like very easy peasy to go, but coming from traditional background, it takes some time to understand this. But rest assured, once we go in detail, each of these we are going to cover. Okay. Then ACI packet forwarding, how the ACI learns the endpoints, how it forwards the traffic, layer 2 unknown unicast, R flooding, everything we will go in detail. Then we have external network connectivity, like layer 2 connectivity from an ACI fabric, layer 3 connectivity, like routing and other stuff. Then we have integrations like ACI can integrate with a VMware, okay, VMware ESX host, and we can do a lot of multiple stuffs inside the APIC. Basically, we from APIC we can control VMware distributed virtual switch DVS. So that's all we are going to show you. Then this is deployment, this service graphs. Then this is management, out of management, because any network a device, that we need a management. So out of band management, in band management, syslog, SNMP services, AAA, like for authentication, TACACS and other stuff, configuration backup, um, configure and upgrade, how to upgrade the fabric, other thing, and ACI anywhere, like a multi-pod, multi-site, and remote leaf, right? So this is like the a type of setup, like multi-pod, multi-site, remote leave. So we are going to cover all of them in upcoming classes. Top like per topic we will take in each class, and we will go through all the technological aspect of all the tips and all the notes. So that is what we are going to cover. So this is like the syllabus. This is very standard syllabus from Cisco, and this is what we are going to cover. Now coming to actual, um, let's start with Cisco ACI, right? So let me stop and share my whiteboard. Stop share, and where's my, yep, here's my whiteboard. Okay, so do you see my whiteboard? Can someone confirm?
Yeah, we can say.
Hari Ram Prajapati. Okay, I see you have raised your hand. Samir R. Do you have any
Yeah.
questions regarding? Go
So
ahead.
when you said Cisco ACI Anywhere, does it mean that we are going to do the practicals, or it would be just a theory in
Cisco.
the lecture?
No, here you are going to get a lab, okay, where you will have one like one spine, two leaves, and there will be your APIC connected. Okay, from APIC we are going to go through all those topics that I told you, like, right. So this is a lab. So everything that is possible in the lab, we will go through each of them, like the policies, VRF, construct, how to configure, how the policies are configured, how the leaf and spine communicate with each other, and how do we do layer 3 out, how do we do layer 2 out, layer 2 out. So all those things which are possible in the lab, we will go through them. So that's a different lab guide and manual and everything workbook that will be shared with you by Network Journey. And we will also have take first theory, and then we will have some lab session, on hand session. Okay, so now coming to
Multi-pod setup is feasible in the lab? Multi-pod and multi-site?
multi-pod. Multi-pods, for multi-pod you need to have multiple APICs, and multiple APICs you need to uh, have, and then the leaf and spine also, because multipod basically involves, just like I will give you a short answer because it's a very huge topic, but in the lab it requires a lot of resources. So multipod in the lab you will not be able to exactly replicate it, even if you do the Cisco lab, the Cisco official lab. It is very difficult to replicate, but if you want to do in a short resource, there are ways that we can do, but here we will not be doing the multi-pod as per the lab, because as I told you, it's very resource intensive as on the virtual system. But we will go through all the topics, all the setup configuration and everything that is possible on the lab that we have.
Okay, thank you.
Okay.
Yeah, hi, Shamil. This side Hariram. Actually, currently I'm working in data center. So my question is, Nutanix is also included on this package, right?
Nutanix. So Nutanix is like the VMM integration you are talking, right?
Yeah, that's correct.
Yeah. So see, for Nutanix, if you have like are you working on ACI already?
Yeah, ACI already, but I'm just wanted to ask, let's Nutanix is also included in this
Uh, Nutanix, like
equipment.
that, yeah. So we have a lab for VMM, but for Nutanix, it require packages, and you need the actual Nutanix setup and all. So we can go through the theory, but you will need Nutanix. You also like know in DCACI, so you have to have the Nutanix. So we'll come to that part later. So let me first start so that everyone I can cover
Sure.
few topics, right?
Yeah,
So these are all advanced questions. Guys, I would really appreciate if you can, what the topics that I'm covering, if we can cover, we can talk about that. And in the end, uh, if you can talk, we can talk about the other topics that you like so that everyone is on the same page. Okay. That will be really helpful for others also. That's okay. So, when we talk about data center, what does it what does it that come to your mind? What is a data center? Can anyone answer?
Like routers, switches, firewalls, all the equipments.
Right. Only router switches firewall?
Servers,
Load balancer.
load
Servers,
balancer, web
load
application
balance,
firewall, DDoS.
right? Proxies and stuff, right?
Storage
So,
also.
right, storage devices, right? Storage devices. So basically in data center, like not just network, we have servers, storage, we have lot many technologies which totally depend upon, which also depend upon network, right? So like I can, if I have to summarize it, it will be like, in three phases, right? The first one would be compute, right? In compute, you will have UCS servers, okay, you will have blades and hypervisors, and then you will in networks, you will have routers, you will have switches, you will have load balancers, you will have firewall, etc. Correct? And the third would be storage. Storage. That would be like, the controllers, SAN switches, uh, Hyperflex, etc. Right? So data center, like all these devices, you will find which like in a data center, it consists of all these devices which are working in a sync, right? Now, Cisco ACI. Okay. So full form of ACI is application centric infrastructure. Okay. So first of all, before we go to ACI, can you tell, we will talk about traditional network. Okay, traditional, uh, let's just forget about ACI fabric and everything. Let's just talk about traditional networks challenges. Can someone give me some points for uh, what are the issues with traditional networks?
Like looping,
Looping. Okay, so to
like
avoid loop,
legacy have
what do we use?
STP.
STP, right? Spanning tree protocol.
So like in the traditional, we were using core, distribution, and access switches. So when it comes
Correct,
to ACI, it will be like only two
correct. So that
types.
core that is called a three-tier architecture, right?
Yes, yes.
Okay, yes. I'll explain that
The
also.
ACI, in the ACI, we will be using like spine and leaf architecture. in
Right.
that
So
APIC
let's talk
also.
about, yeah, let's talk about traditional network issues with traditional networks. So I have STP issues, right? Spanning tree protocol. I have three-tier architecture. So what is a three-tier architecture, right? In our infrastructure, mostly what happens is that one sec, enhance link. Yeah. What happens is that we have this kind of setup, right? This is my core. This is my oh, and let's say this is a switch, right? So what happens is that this is my access layer switch, right? This is my access layer, access layer switch, right? Then this will be my distributor, correct? And this will be my core. This is called three-tier architecture. Three-tier architecture. What does this mean is that what does this mean is that in my three-tier architecture, I have an access switch where my users like laptop, desktop, um, CCTV camera, VoIP phone, anything that connects to my access layer switch. Those access layer switch is connected to distributed layer, and that distributed layer then goes to the core. And from the core, we have like layer 3 SV or whatever, and then we route this traffic to outside like a router or maybe to another tier 3 this infra, right? So this is called a tier 3 three-tier architecture in a traditional network, right? Now, what are the challenges of this three-tier architecture? So somebody said STP, right? STP is spanning tree protocol. So if there is a loop, right? So if there is a layer 2 loop, what happened is that all this distributed switch and this access layer switch and our core, there will be lot of layer 2 flooding and all our devices will have high CPU and it will collapse. Okay, layer 2 is like the most feared, one of the most feared, uh, I would say, scenario that can happen in networking, right? There will lot of outages, lot of it takes a lot of time for recovery from layer 2, because that layer 2 loop, layer 2 storm has to die down and then actual traffic will go. So to avoid that, somebody created STP like, okay, let's just we have two uplinks, but what if I just disable one uplink? Okay, makes sense, right, guys? So if I disable one link, okay, one link is only active. So I have like on theory I have avoided the layer 2 loop, right? But this gives another problem. What is that problem? Can someone tell me?
Increased traffic.
Okay, increased traffic.
Lack of high availability.
Yes, correct. Lack of high availability and wastage of this link, right? So let's just say if this link is, you have this SFP cable or this fiber optic cable is, let's say this is 100 gig and this is 100 gig. So essentially you are just cutting off a 100 gig link, and that is really costly, right? You are wasting your resources, but because you are just using one just because of the fear of the layer 2 loop and STP, right? So this is a real challenge, right? Then if you think like, okay, what I will do is I will just create multiple port channel and I'll bundle them, right? This could be one of the solution. You're not wrong, that is also right. But see, in port channel also there is a limit, right? Can someone tell me the limit?
8 port channel.
Right. So there's like a finite number of links that you can port in this bundle. That is like the limit, right? You cannot expand that. But let's just say that the company is making good profit and I am floor after floor, right? This happens, correct? So companies making good profit, the share prices are rising. We are doing a lot of acquisitions, like generally Cisco does a lot of company like buys a lot of company and other stuff. So we have a lot of users now. We have different floors, but all this traffic has to go somewhere, and it will come here, it will come here, it will come here, and this will got choked up. So at some point, the scalability will be a bigger problem. Do you agree? Right. So I would say scalability, right? What else? The cost because of the redundant link, wastage of resources. Then, so how many of you have to, log into each and every device to troubleshoot or configure anything? Everyone, correct? So if let's say I have to do a configuration or port changes on this number two switch or number one switch, I have to manually log into CLI, and then I have to do configuration, and I have to um, like whatever changes I am doing here, this distributed and this core is not aware of that. Correct? So there's a lot of challenges in the sorry, management and configuration of the devices, right? What else can be there? This is not programmable, correct? We cannot program this, right? This traditional, this traditional, the devices that we get co-distributed, most of them are not programmable, right? We have to like uh, from DNAC or other stuff, we can definitely do some automation. Uh, but you cannot like there is no program. It's like the CLI, the commands are running, but you cannot program it to like do okay if this is the like you cannot give if and else statement like okay if this is the scenario then do this or do that, correct? So these are not programmable essentially. Then there is a lot of time you will see, that server team will come and say, okay, this I want, and so the coordination between network and server becomes difficult, right? Because we have visibility to our side, but we don't have much visibility on server like database and other stuff, right? Coordination. Then this last topic I will take, say, like in it is based on blacklist model. Can someone tell me what is blacklist model? Hello? Anyone can try. It's okay if you're not sure of. We will talk through this. So does anyone know what is blacklist model? Okay, no problem. So blacklist model is that by default everything is allowed. Everything is allowed, right? So how many times we have seen that if I connect a user here, let's say in VLAN 10, and I have another device here in VLAN 10, right? So essentially, if they're in the same VLAN, they can communicate with each other, correct? Uh, Even like if there are on other access switches, we have VLAN 10 and other stuff, right? So essentially everything is allowed on in our three-tier architecture, right? We do have ACLs, but that works on like IP base, and then since like we can have a firewall or something in between to control the traffic and everything, but the network's core role or core job is to forward the traffic, not think of not work as an firewall, right? So we will have to have another firewall, which is again an added burden on this network, right? So these are like few of the challenges of a traditional network. Now let's talk about the benefits that Cisco ACI brings to the table. So now we will talk about Cisco ACI. Okay. So what are the benefits that Cisco ACI comes? So first of all, no STP. What does this mean? Okay. So for understanding Cisco ACI, first let's talk about the two-tier architecture. Two-tier architecture, or also we call as clause topology. What is a clause topology? Clause topology is basically named after Charles Claus. He was the person who named who who invented this and which we call as clause topology. So basically, clause topology or two-tier architecture is what is used in Cisco ACI. What does a two-tier architecture means? Two-tier architecture means that we have only two layer. Okay, this will be your, let's say this will be your core or spine. In ACI fabric we call it spine, and this will be your leaf. Okay, so this will be your spine, let's say spine 2, and this will be your spine 1, and this will be your leaf 1, and this will be your leaf 2, right? So what essentially happens is that this is also called as collapsed core. Why? Because core and distributed layer that we saw in here, distributed and core, these two are basically collapsed and integrated at only one layer, that is this layer, spine. Okay, and this will be your access. Okay, so this is called two-tier architecture or clause topology. So in clause topology, what happens is that my leaf will be connected to this spine, but my leaf will also be connected to spine 2. So the rule is that all the leaves, okay, so when I say leaf is just a network switch, right? It's a network switch, a Nexus series switch, and spine is also also a switch, network Nexus series switch. But the functions of them are very separate. Like they are separated based on the function, right? So in tier 2 architecture, what happens is that we have a mesh-like architecture, like spine 1 will be connected to leaf 1, leaf 2, and spine 2 will also be connected to leaf 1, leaf 2, right? So now if I say, like, let's say my user, or let's just say not user, my server is here, right? This is my DB server. This is my DB server, database server. Okay, this database server wants to communicate with an application server. Okay, let's say this is web application. Okay, now what happens is that this is here. I had to cross 1 2, right? From first the server connected here has to come here. This is first hop. Then it goes to distributed, it goes second hop, then it comes to a core, it's third hop. So within, like, to get out of this three-tier architecture, it took 3 steps. But now comes the tier 2 two-tier architecture. Also, we call it as all the devices in this clause topology is one hop away. So how it is one hop away is that this DB server wants to connect with this web application. It is just one hop away. So from here, the first hop will be spine, and it will come to leaf 2, and then it will be routed to web application. So only one layer is there between DB and web application. So this is very, very scalable. It doesn't like here I have shown you leaf one, leaf two, but in reality there will be multiple leaf, like up to 89, like 20, 30, 40, 80 leaves you can have. Okay, all these will be connected to spines. So irrespective of which leaf you are on, everyone is connected to everyone. Like it is like a very close knit community. So this is called cross topology. Okay, and this structure, this thing is also called as fabric. Okay, this is also called as fabric. So when we will call when we will talk about Cisco, we will say Cisco ACI fabric, right? So there is a reason why we are calling it a fabric. So if you remember, fabric is what? It's a cloth, like it's a cloth, and in cloth, all the threads are woven perfectly with each other, right? They are like very intertwined with each other. That is the reason we call here also. You see, spine is connected to each and every leaf, and all the leaves are connected to like all the spine. So that is the reason it's called a fabric, right? So when we will talk about Cisco ACI fabric, this is what we mean by fabric. So now in cross topology, so first point is like it is a two-tier architecture, right? Now let's talk about STP. Okay, there is no STP. So what happens in Cisco ACI fabric is that all these leaves and spine which are connected to each other, there will be no STP. No spanning tree protocol will run between them. What does that mean? It means that all these interfaces, right? All these interfaces, all these interfaces, all these interfaces, all these interfaces. Let's say if this leaf is connected to spine one, both are forwarding traffic. Correct? It is possible due to ECMP equal cost multipath. So we will talk that about that in our of future lectures. So all the links that are connected with spines and leaf, they are forwarding the traffic. So there is no STP running in between them. So essentially you are utilizing each and every link. So what does that mean? That means that you are not wasting resources, right? No STP, no wastage of resources. Okay. Now coming to next point, this Cisco ACI architecture. If you look at it, you will also observe that uh, this in Cisco ACI, this spine, leaf, everything is managed by APIC. Okay, there will be a centralized control plane which is called as APIC, which will be connected, connected to one of the leaf here, and this will be basically the brain, and through APIC we are going to manage this whole ACI fabric. Okay, so you don't need to log in into each spine, each leaf. All you need to do is log into the APIC, and you can essentially, like, for management, for control, for management, you are going to use APIC for everything. You are going to you want to like configure a port, you use APIC. You're going to monitor the fabric, you are going to use APIC. So APIC is like your centralized management. Centralized management via APIC. Okay. Now I'll give you a scenario. What happens if this let's say this access switch goes down. Okay, now you are tasked with configuring this access switch, right? You are a network engineer. Your boss says that okay, this switch is down. We need to RMA this. What would be your step? Can someone answer? Anyone? I'm audible?
Yeah, Samir. Can you mention again which switch is down? Switch number 2 or?
Yeah, any switch. I am just saying, taking an example, like a switch is down. Your boss says, Uday, this switch is down.
Right.
So in traditional approach, what you will do?
The basic troubleshooting is to find out are the uplinks looking
No,
good,
I am
their
saying,
connectivities.
yeah, I'm saying the switch is down. We need to RMA the switch. We need to replace the switch. Okay, we got the new switch. Now you need to configure it.
Yeah, might be I will first have the remote engineer on the site to do basic configuration and give me the management access. And
Okay,
if
remote.
Ansible is used, I will use the Ansible playbook for config deployment. Otherwise, manually configure the switch.
Okay, Ansible if available, right?
Yeah, only if. Yeah.
But yeah, you will need to like copy paste all the config, right?
Yeah. Yeah. Manually, then I will take remote control once I have the management access. And then
Right. So see how many steps are there? 4 steps, right? But when we come to Cisco ACI Fabric, so as I told you, we are managing everything from Cisco APIC, right? This APIC. So if anything goes down, it will be a plug and play. My let's say for some reason my leaf 2 goes down. Okay. I need not worry about. Okay. I need not have I don't need anyone to give me a management access. Then I need to configure. I just need someone to connect the new switch. Okay, let's say this is a new switch. Okay, new switch NS. I just need to tell someone or a data center operation guy or someone that okay, go and connect it to this port. That's it, right? Once this is connected from the APIC, we are going to
It will take the VTAP IP, no? Right?
yes, that is like the how it will be configured, right? But first step, like you don't need to have like someone give you a management access. You just need to connect it to the ACI fabric, correct? Once this new switch is connected to your ACI fabric from APIC, you will be able to see this new switch. Okay, you can once you see this new switch, you can onboard it on the ACI fabric. Okay, you can push the last backup, last uh, last configuration that you had, because APIC will so APIC knows everything about ACI fabric. Okay, APIC is like the brain. Just think of APIC is like a brain. Okay, and is this ACI fabric is the body, right? So APIC knows everything. If this leaf goes down, it does not matter. It's just an hardware. You just need to connect the new switch. You just need to power up and just connect those uplinks. My epic will know this is a new switch, and you as a network engineer, you just need to select that leaf or that switch that went down to push to this new switch, and all the configuration, all the software version, everything will be all this software version, everything will be pushed from APIC to this leaf, and it will come into the ACI fabric within like very less time, and you don't have to worry about a lot of others management stuff. So from management and configuration, it's easy to manage and configure. Got it? It's very easy. Now next thing is that this is programmable. So APIC or Cisco ACI is a Cisco ACI is basically a SDN solution. What is an SDN solution? Can someone answer me?
It's like software defined networking where we can programming with the API or with the
Yes, yes, correct. So software defined network. Okay. Oh, so see this. What does a software-defined network means that okay, traditional network we have hardware, we have like some iOS OS running like on them, and we don't have much I would say flexibility to have a code or program run on that, and based on that program we can take the action that okay, this should be allowed, or if these conditions are met then this should be denied or not, right? Something like that. So right now the DC, like if you ask like why Cisco ACI is trending, one of the main reason is it is a software defined network. Okay, so we have a logical part which we call as a logical construct, and there is a physical part like our ports, or VLAN, our ports, actual ports, switches, they are like physical part. So we are bridging them, okay, and we are calling it a software defined network. So what is a soft? Let's just give me a little brief about SDN. Okay, so what is the condition that for a software defined network? It has to be a centralized. It has to be a centralized controller, right? There should be a centralized controller. Then it should be a programmable, because that's why we are using software defined network. Like it's a software defined and it has to be programmable. Then there is a separation of control plane from your data plane, right? And then it has to be less expensive in the terms like OPEX and CAPEX. So OPEX is like your operations cost, like day-to-day operating cost, and capex is your one capital cost, like the one-time cost. Let's say you buy a Nexus switch, okay, you buy it for 1 lakh rupees. That is your ca- capital cost, and operations will be, let's say, to run it daily, like to manage all the engineers and all the power resource and everything is like, let's say, 1,000 rupees. That will be your OPEX. So 1,000 per day. That will be your operations cost, right? So it has to be a less expensive. And next is it can integrate integrate with your applications. So this is very important. It can integrate with your applications, right? So why we are coming into a software defined network, or not just like Cisco ACI, but all the solutions that are in SDN. Let's say talk about VMware's NSX, right? Uh, we have Cisco Viptela. That is also one of the SDN solution. So why we want? Because we want to integrate our network with applications, right? And that is the reason when I say APIC, the full form of APIC is application one second, guys. Yep, sorry. I Okay. So what is APIC? APIC full form is application policy infrastructure structure controller. Okay. So you see app Cisco ACI is application centric infrastructure. So the solution itself says like the network, this technology is centered around applications centric, right? So we want to decouple the network and we want to couple it with application. So my network should not dictate the application, but essentially it should be the other way, that my application should dictate how my network is going to be, correct? So that is one of the reason we have, we need to integrate it with our applications, and that's one of the solution when Cisco came up with Cisco ACI. Now, coming to next part, that monitoring. Where's my cursor? Okay, here it is. So monitoring is very easy here. Monitoring faults and errors. So since on APIC we have everything on APIC, we have everything. We have this is a centralized. What's happening? Okay. Okay, so this is centralized management, like from by APIC. So due to that, we have a lot of visibility into all these switches, all the leaves, all the spines, everything. We have very granular. We can know what is my current bandwidth, if of any uplink, if it is shooting up or not, if there is an error that is coming up. So all those details we will get on from one GUI, that is APIC. From APIC. APIC is like the brain, and it will know what's happening in the fabric. So we don't need to go to multiple tools like SolarWinds, like CAPM, and other things to check what is the status. I just if there is something wrong going on, if there are some errors that we are seeing, APIC will note log it, and it will show you in a very presentable manner in APIC GUI. Even it gives us score of health score of like how healthy my device is or my network is, and based on that, so if you are working in DCACI already, you know that the most of the tickets or task we are like you would be getting would be about these errors, faults that are happening in ACI, like APIC and ACI Fabric. So you'll have your day-to-day task will be to check all that and remediate, right? So that's one of the thing. And most important, why tier 3 architecture, and why tier 2 architecture? The one thing that differentiate is that, do you know about north to south traffic, north south traffic, and east west traffic? Anyone?
Yeah, north to south is internet to LAN, and east west is between servers.
Correct. So this tier 3 architecture is essentially a south to north architecture, right? So it's like south to north. How? If you see this architecture, my user here, whatever my traffic is essentially going from down here to up here, right? So it's called south to north, right? But this approach is not good if you have like applications that are running in data center, which requires a very less latency. In data center, the traffic that we are most concerned with is east to west traffic or west to east traffic. Okay. So north to south, there will be a lot of hops is there. This and three-tier architecture is the best example. But in here, cross topology, you will see that this is east to west traffic or west to east traffic, whatever you are called. But it is east to west traffic or west to east traffic, right? Because what happens is that this is my let's say this is my one web application. Okay, some developer is developing this application. Let's just say here a developer is developing this application. Okay, or not just that. Let's just say this is a Netflix web server. Okay, Netflix web server. So we know there is a new movie or new series coming up, which is very famous. Which is very um, has a good reviews and everyone wants to watch it. Now what happens is that you have a user interface here, right? So this is like real life, real world example. Do you have a user using its mobile? Let's bring him out of ACI Fabric. Okay, there's this user. He's on his phone. Okay, So here this user is on phone, desktop, laptop, anything like, and he's browsing the Netflix, right? So he says, oh, okay, there's a movie, fine. So this is the front end. You will see just the list of the applications and everything. But now comes like when I click on that show, whatever show X, Y, Z or ABC that show is, okay. What will happen is that this application needs to fetch that actual file or that actual data from the database somewhere in my data center. that that show or that series or that film will be residing, right? Let's say that is on this database. So what will happen is that once the user clicks on this show, okay, let's say this this new movie, this application will request and fetch all that data from the database, okay. And now let's say this Netflix user is using very HD quality. And not just that, let's just say HD quality, he's like preferring for HD quality. And not just that, at the same time, because this is a very popular movie, there will be many users who are like querying this data. Now there will be a load of requests coming to this database server, which will be asking, okay, give me the movie, so that I can bring that movie to this application server, and then I can show it to user. So this latency becomes very critical. This latency here, this latency here becomes very critical. Let's just imagine if you have the latency of a north to south traffic, it has to cross a lot of paths, all the bandwidth, all the utilization is coming. That will choke up your infrastructure. You don't need that. Your business relies on the data, on the speed at which the user can access the show and everything, or they will just ditch Netflix and they will go to Geo Hotstar maybe, right? So this is very critical, and you want this latency to be as minimal as possible. And for that, we are using two-tier architecture, and Cisco Fabric uses this two-tier architecture to keep this as minimum as possible. And also it enables us, because this is application centric, it is aware about this application also. So APIC will, we in future classes we will talk about endpoint groups. So we are going to group them in database. Like there will be multiple database, there will be not just one database, because definitely let's say 1 lakh users are at a time watching cricket match. So there will be a lot of database here. There will not be one database. If there will be only one server, and that it cannot cater to everyone. So there will be a lot of database here, which will be storing that data. That data, let's say that movie is there, so this movie will be here, right? So all this querying,
Sorry
everything
to
will be.
interrupt here. Then
Right.
what is this difference between the application centric and the network centric in this case?
Yes. So, yeah, application centric. Let me come to that. So, application centric is that. So, this movies, this, let's say this NNN, this all are in the same database, right? This database. This is an application. Let's just say this is Netflix application. This database. What I can do in ACI Fabric, ACI Cisco ACI is I will group them together, so that this will be part of my one endpoint group, and that endpoint group I can then allow, deny, or I can decide how I'm going to allow these endpoint groups to talk with the application. And it will be irrespective of where they are connected in ACI Fabric. It does not matter if I disconnect here and I connect here. This ACI Cisco ACI Fabric will know this is part. I just need to tell, okay, this is part of this endpoint group, and this will, like, wherever switch it is connected, this will be a part of this group. So we are basically grouping grouping based on application. It could be, so here I have taken example of database, but we can group it based on application. We can group it based on servers. So different things, different scenarios are there, which we'll talk about in future. So for now I just stop on this part, because this is one one whole topic in itself. Okay, so these are basically few of the benefits of Cisco ACI. Okay, Cisco ACI and traditional networks, what we get from the Cisco ACI. So Cisco ACI, Cisco have a, like, uh, habit, I would say, reputation of um, acquiring companies. They did with Splunk, Thousand Eyes, and whatnot, ASA, FTD, everything. So Cisco ACI used to be interesting. Like it's just for fact. ACI used to be one another company. I think if I can recall, it's something like INS or something. So Cisco basically bought that company. Okay, and since Cisco is already in the data center domain, like very heavily, they have storage, they have compute, they have switches, they have routers, they have firewall. So they, heavily modified it, and they on that solution, and now it is like, the final product. What we see is Cisco ACI. So just to let you know. Now coming to next, that I would like to tell you about is that. Uh, so yeah, before I go ahead, anyone has any questions here? This was just comparison of traditional networks and Cisco ACI. Great, good to see nobody has.
So in one EPG can have multiple bridge domains, like different subnets with one
Uh,
EPG.
yeah, yeah, we will talk about that. So, and yes, we can. Yes, it has, but in future classes we will go into more detail about bridge domains, EPGs, and other stuff. Okay, so okay, moving on to APIC. Let's talk about the APIC because that is our brain. Okay. First, I will also like I want to show you the hardware. Okay. So in Cisco Nexus Nexus series, we have hardwares 9000 series hardware, right? So let me just zoom it a little bit. 9000 series hardware. So we have 9500. We have where's my cursor? We have 9300 and we have 9200. This is all I'm talking about Nexus hardware, right? Now for Cisco ACI, only we can use 9500 and 9300. Okay. And what is the difference? How? So there are two operating systems. There's an ACI OS and there is a NX OS. So if you're already aware of NX OS, it's called Nexus OS. Okay. So if your switch you have installed NXOS, then it will be just used as the Nexus. It will not be part of Cisco ACI. To configure it into the Cisco ACI mode, you need to have ACI operating system installed on 9500 and 9300. Okay, and only 9500 will be your spine, and 9300 we can. There are few models which can work as a spine, but mostly 9300 you will see as leaf, right? Then we have 9200 models that are mostly NXOS. Okay, 9200 we do not use in ACI Fabric. Then we have our other model that is 7000 series Nexus series, which what we call 7Ks. We have 6000 series. Then we have 54 and 5500 series. Then 5000 series basically. Let me write like this: 5000 series. Then we have 400 series. We have 300, 3000. Oh, sorry, 1000. 3000 series. These are like very specialized. This is like for IBM specialized one, and this is for like HCTs, high compute trading. So this you will not see in your day, like you'll not see most of the time. It's very rare to see 4000, 3000. But they are there. Then we have 2000 series, which is mostly like used for fax, right? In fax, like we have 2300, then 2200, and 2100. And then the last series that we have, the virtual one, that is 1000 V series, right? So for Cisco ACI, you need to understand that we are going to use 9500 and 9300 only. Now let me show you the hardware. Here it is. Can you see my screen of the hardware? Okay. Can everyone see my screen with the hardware image? Hello.
Yes.
Yes, we can.
Okay, thank you. So in Cisco Nexus 9000 series, we have 9500 series, which is actually called a modular chassis. Okay, why it is a modular chassis is because, see, like this, it comes in slot, 4 slot, 8 slot, 16 slot. So this is like 4 slot. This is like the big one is a 16 slot. When I say slot, I mean this one, this 1, 2, 3, 4, 5, 6, 7, 8. See, this is a 8 slot chassis. You see this one 9500 platform, it's so as per our requirement, we can insert these slots. Okay, we can reduce or increase, like, we can just buy the chassis. We have a need for 4, we can use 4, and we can leave the rest of the 4 for future expansion and other stuff. So that's why it comes in 4 3 configuration, 4 slot, 8 slot, 16 slot. It supports 10 gig, 40 gig, 100 gig, and 400 gig modules also. It's as per our requirement we can purchase. Then we have 9300. So okay, before we go to 9300, let's talk about 9500. Okay, this is how it looks. This is how it looks, the 9500 platform modular switch. This is essentially a 8 module 9500 switch, and you can see these are the line cards that just highlighted. Okay, this could be 1, 10, 25, 40, 50, 100, like whatever the configuration you want to integrate in your data center. Then we have 2 supervisor modules, basically for management and supervisor modules. And then we have this for 2 fabric modules. Okay, we can have up to 6 purchases. So what does a fabric module does is, these line cards are like, it needs something. So this line, let's say this line card wants to talk to this line card, or the traffic wants to go. So this needs to be interconnected. So this fabric modules, what it does is that it connects all these line cards in one in on one fabric model. So it's like, it's like this is a fabric model. Okay, and this is my line card. Okay, so all my traffic is basically in the switch. It's talking each to each other via these fabric modules. Okay, then we have fan trays, we have system controllers. Okay, this is how it looks. Then we have the 9300 switches. Okay, so 9300 switches, we have some switches which can be configured as a spine, but most of them will be a leaf variety also. So 9500 you will see only as a spine. Okay, and 9300 you'll always see as a leaf. Sometimes we can have some modules which is also spine. So here's an example of 9300 ACI fixed leaf switches. So this is like 9336C FX to 40 36 ports, 40 into 100 gig, 40 and 100 gig capacity, 40 and 50 gig capacity. Okay, so these are few of examples. And what so there are like, 2 generations of the leaf of this switches, Nexus switches. So the older version is all the older version, it starts with P. So all the previous generation was P generation. It anything starts with PQ in the ending. You know that this is like, the older version. So now, right now, if you buy any device, any Nexus, you'll mostly see EX or FX. That is the next generation. Okay. Then for APIC, so this is all the switches. Okay, this is like the, as I already talked about, it's like the body of the Cisco ACI fabric. So what about the brain? So for Cisco APIC, you need to install the APIC on Cisco UCS server. So there is like C2220 M3 first generation, C20 C220 M4 second generation. So your APIC, okay, APIC will come installed on this UCS server. Okay, uh, how you configure it in the starting is that, you take a management console, you take a basically SMIC control. You take via keyboard, laptop, you configure like basic details like IP, VTAP IP, management IP pool, and number of APICs and leaf and switches, the pool management pool. So there are like few basic configuration that you need to do. Okay, before this APIC can be managed via like GUI. Once you have this configuration done, this is like a just and the CLI pop-up that will come in the starting. Once you have all of this configured, you can then access the APIC server. Once you have the APIC server up, then you can you can find the spine, leaf, and the whole fabric. Okay, so discovery of APIC is like, let me show you. So this is a typical standard architecture of Cisco ACI. There will be spines, leaf switches, and APICs. Okay. There will always be three APIC controller. That's why there are three APICs. Then we have leaf switches. So the rule is that everything in a Cisco ACI fabric, every device, anything that is connected to fabric, it has to be connected to the leaf. Nothing will connect to spine. So you cannot connect any server, any firewall, any load balancer to the spine. No, that is not allowed. On the spines, or the spines will only be connected to the leaves. So basically the function of the spine will just to forward the traffic from the leaf to other leaf. Okay. So that is the only thing the spine will do. It will not like connect any end devices to itself. All the end devices has to connect to the leaf switches.
We
Now,
required only three epics, or can't we have two, four, something like this?
no. So see, you can have, but in your production, you need to have minimum of three APIC servers. That is like the recommended one. Okay. In our lab, you will see we just have one APIC server. So because this is a lab, you can do basic stuff with that. But in production environment, you need wherever you will always see in ACI that three servers will be there. So there's like thing like if one server goes down, the other two can take, but you will get the error. But other two can run the ACI fabric. But if the second one goes down and only one APIC is remaining, then it will be difficult. Like you cannot do any write operation. You can do read operations, but you cannot do any write operations. So there is like a logic behind this. Like the Cisco has put some rules how we have to configure the ACI fabric. Now coming to APIC. So APIC first we need to bring the APIC up in the network. Once our APIC is up, okay, it will detect the ACI fabric. So ACI fabric, it will know the all the devices like leaf switches, spines, whatever they are, by process of LLDP. Okay. So by using LLDP protocol, APIC will discover all the leaves and spines in the ACI fabric. Once I have my APIC up, I will slowly and surely, discover all the things. So there will be LLDP packet exchange between leaves. So first this leaf will come up. Then this leaf is connected to two spines. So then APIC will see two spines. So then this spine will come into network. So once the spine is come up, the spine is connected to multiple leaf, and APIC will automatically get to know all the leaves that is in the network. So now I'm going to take you to the lab. Sorry. Um, let me know if you see once you see my APIC screen.
Yes.
Perfect. Oh, failed local authentication. Why? Okay, so this is how the APIC looks. Okay, this is the APIC GUI. This is when I have configured my APIC with basic management and everything. since I have my APIC up, it's giving me a start ACI Fabric setup, but I would say no. I'm going to discover the uh, devices, leaf and spine from my APIC. So how we do that is that with the LLDP process. So in APIC, we go to Fabric. Okay. In Fabric, this is everything about Fabric, right? You see Fabric membership. And in Fabric membership, there are registered nodes. So if any leaf or spine is registered in ACI Fabric, you will see all the lists like serial number, model, pod number, node ID, name, and everything, maintenance mode, and everything here, all the details. So since this is a new is ACI Epic, there is nothing here, right? I'll go to nodes pending registration and see. Sure, there is a leaf that APIC has discovered by the LLDP process, and the node, or because we call the leaf and spine as node. So this node is awaiting registration, pending registration. So I need to manually register this. Okay. So my pod ID is one only. I have to give a node ID. So node ID will be like um, a serial like an identification for this leaf. So this leaf is basically one of the switch. I'm going to name it as leaf 101. Okay, you can name it as per your company guideline. So APIC is very smart, right? Once any device is connected, okay, it will know if it's a leaf or spine automatically. So see here, it is telling me that it's a leaf. Okay, node type is a leaf. So it's already selected a leaf for me. If there would have been a spine, it will say me, okay, this is a spine, and we need to onboard this switch as a spine in the APIC. Now I'll just go ahead and click register. Now what will happen is that once I have clicked this registered, this leaf status will go unknown. So right now there is in the background, there's a process going on between the APIC and the leaf. Okay, APIC is checking the leaf's software version and everything, and it is determining if the version is up to date with the APIC or not. Then it will assign one of the management IP, VTAP IP to the leaf. Okay, this is all happening in the background. I have not done anything. It is that simple and that easy. So I have not done anything. So this process is going in the background. I just need to refresh. Once that process is completed, now you see this is removed from my nodes pending registration, and it should come up in my registered node. See, this has come up. So now I see that this is a 9396 PX model first generation. Okay, status it's coming inactive, so it will take some time to become active here. It's still in the process. So see, the APIC has already assigned it 10.0.120.64/32. So all the IPs will be /32. So this is the IP VTAP IP management IP that the APIC has automatically assigned it to the leaf. Okay, we do not need to do anything. Once this node is registered, the status will change. Okay, and once that is done, then it will start this. Okay, it has already started discovering. So this leaf, once this leaf is connected, the APIC, we onboarded the leaf 0101. It identified that, oh wait, there is another device switch in the ACI fabric, which is a spine and which is pending registration. So it also wants to be part of this ACI fabric. I'll say, okay, let's onboard this, and I'll say, 201, and I'll say 201 spine node name. So see, it is very smart. So it has automatically understood that this is a spine, and I see the role as spine. I just say register, and now this status has gone into unknown. And again, the same process, LLDP process, software checking and everything. It's all ongoing in the background. If I come to registered, you see my status from inactive, it has gone to active. You see this? This is visible, right? This is not very small. You can all see my screen, correct?
Yes, yes.
Great. So now it has become active, and in some time, this spine will also be removed from here and it will come in registered nodes, right? So now what's happening is that I am onboarding the devices on my APIC, on my Cisco fabric, Cisco ACI fabric, because APIC is the main brain, and it will discover, and it will associate all the spine. And now it's in discovering. After unknown to discovering, then it will go to inactive, and then it will go to active. Okay. Then it will, once we have the spine, it will again search. It will again search for any other pending devices that it sees in ACI fabric. So this discovery is like automatic. It will automatically keep on searching. Or whenever it sees anything, it will show me. If I don't want to register it, that's also fine. I can not register it. I can, like, decommission it, or I can do it, put it in maintenance. So lot of options I can do. If I go to this topology tab, I will see a topology of how logically my ACI fabric looks like. I have come to topology. I have come here and see. This is my APIC. Okay. It is connected to leaf 101. Right now my spine is in discovery. Once my spine is discovered, it will show here as spine. And once the spine is discovered and other leaves are discovered, we will be able to see the whole topology here. We don't need to go anywhere. We will see the whole topology of how each and everything is connected here. Not just like this, all our endpoints, either server, firewall, routers, we will be able to see. So we can, even go to interfaces, and we can see like what interfaces they are connected with, right? So I need to come to this leaf. Let's say this is my leaf, right? Leaf 101. I go to interfaces. So see, it is giving me a summary. Like I have 12 uplinks, 48 downlink. Should not click. Okay, FX links 60 total interfaces are there. What is the hardware usage, memory, UPU, CPU, everything will be there, right? Management interfaces, how many VPCs are there, how many SVIs are there. So it is giving me a lot of information just from this GUI, this one dashboard. So I can go to dashboard, I can see faults, like if there is any issues in the system, how healthy my system is, okay, what is my health score and everything. This is something we will talk about in detail in future classes. Then topology wise, see, it has detected the spine now, so spine is coming up here. So it's showing me like, okay, it's connected. If I go to interface, I can see which interface is connected. So this green one, 41, 49, these are the ones that are connected, right? So this is 41, this is connected to controller, and this is 49, this is part of usage is fabric. So I get a lot of information from here. I can click, I can check what is the interfaces, what is the details are there. Okay, deployed EPGs we will check in future. So I can check the model, I can check the uh, firmware version, I can check the IP address, it is assigned name, node, right? I can check the health, what is the health of the leaf. It'll take some time to load. I can do a lot of troubleshooting things. I will have here any history, like if any kind of logs, anything happened, I will like it anything happened on on the switch, it will give me in the history. So from this dashboard, I have everything that in traditional network I have to log into a switch and then check everything manually using multiple of commands. I don't need to do that here. So this is what your leaf will be, and the same thing will be spine. I can go to spine, I can check the topology, I can check the interfaces. So this is a this is a modular, and this is 8 modules. So see, 1, 2, 3, 4, 5, 6, 7, 8, and we have modulars, we have slots in 5, 7, and 8. Out of that, on 5, 0, 1, and 0, 2 are connected, right? The others are not connected. Okay, so I can check all the health, I can check fan power status, everything. I can very granularly, at a very granular level, I can check what's happening, like if I click here, so it will take me to physical layer, what's happening. So basically a lot of things that I can do from the APIC fabric. So with that, I will conclude this demo class. I hope you had uh, like you had a good understanding of what I explained, and share my other screen. whiteboard. Okay. So guys, do you have any questions for me? Hello. Hello, I'm audible.
Yes.
Can you share the topology we would be working? Like, other than these, will there be any servers or VMwares we would be connecting it?
Server VMwares, we there is a VMware server like we have VM. So you need the lab, right?
Yeah,
Yeah.
on which
So
we would
yeah,
be
that
accessing.
you will be shared of the lab by network journey. Let me give you the contact details. So here's the contact detail for admission, pricing, batches, timing, lab, and what you will have in the lab or not, everything. It will be provided by Sajid or anyone from network journey. These do you see my meeting chat?
Yeah.
Okay, thanks, Hariharan. So message to everyone. Okay, so you need to contact for admission, pricing, and other stuff. This like network journey guy who manages this could not join this. So these are the details that you can reach out on WhatsApp, and we will go through all the topics. Okay, we will talk about all the technologies. We will talk about as per the DCACI syllabus. We have the workbooks, the labs are there. You will provided lab access. So you will have the access let me just copy paste and okay, where is my whiteboard? Okay, here is my whiteboard. Let me go to new whiteboard. You see my whiteboard? Do you see my whiteboard?
Yes, yes.
Okay, so okay, so this will all be there. I'm not from the admissions team, so this is all the details that you will need, and you can contact these numbers. They will provide you more details of class, schedule, batches, pricing, and everything. And okay, so that's all from my side, everyone, and I'm looking forward to seeing you in our next classes so that we can go to the ACI. But yeah, you will learn a lot of new things about ACI. You will definitely will try to make it more knowledgeable. I would like you to ask me questions, and I would like to answer, and uh, share my knowledge, the experience that I have in data center in ACI, uh, and these are the phone numbers that you need to contact. If you have any questions for me, you can ask me.
So, Samir, I have one question. If we deploy Cisco ACI in a data center environment, can we know the east-west traffic?
Yeah, you can. So see, the Cisco ACI is majorly for east to west traffic, right? We
Okay.
we need we need less latency. We need between our applications, our database, our web server or whatever, all the applications that
Mhm.
are running.
So
So
basically,
east
we
west
can.
traffic is the main thing for Cisco ACI.
Okay. So basically, then we can for seeing east-west traffic, we need to enable IPF or not IPF. It's a S-flow or net flow, something kind of a thing. Or we need to install any kind of application inside the server itself.
Sorry. Can you repeat your
Uh,
question?
when
Who's
we want to see a
Hariharan?
east-west traffic,
Yeah.
this will be enabled on a hardware fabric or it will be on a software level also. Software level means inside the server or we need to enable anything else or what?
I did not understand your question, Hariharan. What exactly
Basically, the
you mean to
east-west
install?
traffic from server 1 to
Yeah,
server.
so the traffic itself will be east-west. The in
Mm-hmm.
ACI, like whatever the connection communication is happening, it's east to west. Even if like if it's a network, let's say it's a firewall to a load balancer, it will be east to west, right? Because
Okay.
this is a two-tier architecture,
That
right?
basically I have worked on this Arista environment. Okay.
Okay.
So where we have the leaf and spine and the
Right,
same
right,
underlay
right,
and overlay, all kind of stuff. I have.
right.
But when we want to see a east-west traffic on a switch level, we are enabled the syslock, sorry, S-lock.
Okay, okay, okay. You call
Okay.
it. Okay, okay. You
After
got
that
S
thing,
flow.
uh,
Okay,
after
okay.
that thing, we have enabled S-flow inside the this thing also. What we tell inside the server also. Then only we come the accurate traffic from which server which traffic is and where it is flowing. What about in Cisco ACI? Whether it will work on that traditional way or it will automatically capture to the hardware level only, in the hardware fabric level only.
Okay, so in Cisco ACI,
Mm-hmm.
in APIC, when we define endpoint groups, servers, and everything, right? So APIC is
Mm-hmm.
already profiling them, right?
Okay.
So in Arista, are you using CVP?
Yeah, CVP we are using. Cloud Vision, no? We are using.
Cloud Vision portal, yeah,
Yeah.
for overlay, underlay management,
Yeah.
everything, right?
The Cloud
Yeah.
Vision we are explored it, but
Mhm.
we are not happy, though we went for a SolarWinds.
Okay, so you chose a third party, basically
Third one.
third
Correct.
party for SolarWinds. Yeah, okay, right. So in APIC also, like Cisco does provide you like monitoring. We have telemetry and other things are all there. You can even
Mm-hmm.
you import that data to some other tool like monitoring tool if
Mm-hmm.
you want to. So all
Mm-hmm.
those functionality, like it's similar. It will be in the APIC also. So yeah, it will be in the APIC also.
One more question. If that it is APIC. APIC is connecting to the leaf, correct? APIC is the
Yes,
basically
yes.
is the out of band management server, correct?
Ye-
It
It's
looks like that only. If
yeah, like I would not say out of band. Out of band management is for us to access, but it's not out of band. It is in the ACI fabric,
okay,
APIC, and APIC is actively like monitoring, and it is like doing the management. The control plane is with the management plane, and everything is with APIC.
okay.
So, right?
If
So.
if I got connectivity loss between leaf and spine,
Mhm.
then it will work.
Leaf and spine.
Yeah.
So you are saying your APIC is connected to leaf and that leaf goes down.
No, no. The spine goes down.
Yeah, okay.
Leaf,
So it will
ah.
if the spine goes down, so this is a mesh fabric, right? This is a Cisco
Mm-hmm.
ACI fabric. So
Mm-hmm.
each and every leaf is connected to each and every spine, right?
It is the two spine is there only, correct. If
Correct. So
both
if
the
you're
spine is got down,
right,
then the ACI is connecting to the one or two leaf, correct. If I have
correct,
connected
correct.
50 leaf, then what will be happen on this scenario?
So see, if your spine is down,
Mm-hmm.
okay, if your both spine goes down,
Mm-hmm.
you will have a P1 out incident.
Okay.
Because your spines are connecting to leaf. Your leaf are not connecting to each other. So
Correct.
in ACI fabric, your leaf like everything connects with spine. Your
Mm-hmm.
leaf connects with spine. There will be no connection between leaf to leaf. Okay,
Right.
everything is forwarded from the spine. So the scenario you're telling me is very highly unlikely. It could be like on a major catastrophic disaster or something. But
Mm-hmm.
if that happens, rest assured it will be like the highest P1, and there
Correct.
will be a lot of questions about architecture and
Correct, correct.
yeah.
Because we have deployed architecture in whatever the thing is connected, we have
uh
connected out of band management only, not
Right, right.
connected on the fabric port.
Right. So like you will not have just two spine. You will
Mm-hmm.
most probably have like four spine, three spine, right?
Mm-hmm.
It depends upon how large your fabric is, and the whole redundancy point of having multiple spines is the same thing. Like if one spine goes down, it will not matter. You will not even feel the heat because the other spine will
Will
work.
take care.
Yeah, because it is ECMP, right? Equal cost multipath. So it will not matter. It will not matter. It is based on per flow. Your path is chosen. If one path goes down, the other all other paths will take via the spine that is up. If all goes down, your ACI fabric is down, and there will be a lot of running around. Say people say trying to save their jobs. So that will be that will be the scenario. So I hope I answered that question.
Sure, sure. Yes, yes.
Got it. So thank you everyone. I really appreciate everyone sticking till the end, and I really hope to you know have given a good knowledge about this to everyone. And you can contact for admission pricing, other thing you can contact this, and hope to see you in the next lectures. Thank you everyone. I'll be ending these sessions now. I appreciate everyone. Have a good day.